Well, it's a while later now, and the postman has brought me a few more bits and pieces to play with, so I'll just show you some of the other prototypes that I've been making with these. One of the things he brought me was this big bottom bracket bearing, so this is for a bicycle, and I wanted this because it is 30mm inside diameter. And postman also brought me this. This is a 30mm outside diameter carbon fibre tube. It's a little bit heavier than I had hoped for. It's quite heavy actually. It's 50 centimeters long and it weighs 110 grams or 108 grams or something like that. But it's super rigid. And the reason, it's a little bit hard to show you, but the reason it's so heavy and rigid is that this wall is actually 1.5 millimeters. I wasn't really thinking about that when I bought it, but yeah, it's heavier than I wanted, but it should be okay. So it'll be about 50 grams because I'll be using about half of this length. And what else did the postman bring me? He brought me this little motor. This is the cute little stepper motor. So this is a NEMA 8 and it's 30mm back to front. So it's about the smallest you can get in this like shape or this form factor of stepper motors. And it is quite weak, but all it has to do is move this very light hand on the end. So that shouldn't be a problem. So I have done some more cutting of acrylic and I've made up this prototype to test how the wrist or the hand was going to move this, and I went through a few iterations of getting this distance right between this bearing and that bearing, and I'm glad I did because boy, it turned out really nice. So it's super smooth and yet it just stays where you put it. So it's not gonna like fall down like that when the power goes off. And even with this on, this is only like, what was this, 11 grams or something, so it makes no difference whether that's on there or not. And it's also quite easy to move from here. I've just got an extra bit of bearing steel sticking out this side, and see if we can focus on the middle bit there. So those two gear things in there are fixed to the shaft because the belt coming in from the elbow needs to turn this one, and then that's going to obviously turn this. So there's a gear reduction of about, I think it's 4 1/4. Yeah, this is 16 teeth and that's 68 teeth, so it's 4.25 increase in torque and reduction in speed. It would be nice to have a little bit more, but I mean, this wheel, obviously you don't want it to get too ridiculously large, and if it was any bigger than this, it would start to stick out in front of the shaft on this stepper motor, which we don't really want because this has to go on there. And because I've cut this so finely, I can actually put it on there and it stays on there, and I can just sort of get a look at what it's going to look like when it's all done. So it's yeah, that's what it's going to look like, hopefully. And again, it doesn't make any difference whether that's on or not, it just goes, it stays where you put it, which is really nice. Oh, almost. Oh, it falls down a little bit there. These wires are going to have to come a little bit to the side like that. Now that I have a larger tube, these wires can go inside the tube too, which is quite nice. So it should be able to get all the way up to there and all the way down to there, or roughly. I think probably just to be safe, it might be best to keep it to within this 180 degree range from there to there, just to start off with. Yeah, so anyway, if this gear here was any larger, it would start to get in the way of this, which is just sort of, actually didn't think about this, but it's turned out to be just, has just enough clearance to get around when that turns. So this construction here, now that I'm using a 30mm pipe, this thing is a whole lot larger, which is why I can fit in these two side-by-side gears here. Although to get this middle gear right in the middle of the pipe, it's not right in the middle, but it's pretty close, and it's kind of important that it is in the middle because this is going to twist around there, and if this gear was, say, at the top, it would twist and it would get further away from the one at the back, or it would twist it around more than it needs to be, and the distance for that on that belt might change too much. So anyway, we want that to be right in the middle, and you can see I've actually these gears have a little bit of a lip on them, so the one at the top there you can maybe see has a little bit of a lip on the other side of the belt. And I actually filed that off on this one just so that I could get it that extra millimeter to the right and closer to center. That worked out okay. One thing I didn't like about this design originally, which is why I was a little bit reluctant to try it, was that on this pivot here I can't get a hinge or a pin to go all the way through. So this piece here, this bearing thing, is going all the way through. I can't do that here because the motor is in the middle of where that screw would go. And I was a little bit worried that it would sort of, when the belt was pulled back like that, these two screws would bend back a little bit like that. So this one would bend, oops, this one would bend like that, and this one would bend like that, and it would sort of go a bit sloppy. But what I've done here is I've used two on each side of this. Is a 6mm block, and the gear of course is 6mm as well, and these 5mm diameter screws are just screwing directly into that and going all the way in until they bump up against the stepper motor, and I'm just turning it fairly firmly there. I don't think it's going to damage the stepper motor. Those laminations there are pretty solid, and actually it works quite nicely. It doesn't feel loose or sloppy or anything like that, and because there are bearings here, I can just use normal threaded stuff here. I don't need to use a smooth outside surface like that one. It can just be a rough thread and it's fine. It just turns really nice and smooth. So I'm quite happy about that, and it's all fairly compact. It's not that light though, unfortunately, because this thing here is getting a bit heavy. But the way that I am planning to finish this off is to get some shorter screws. So these screws are 20mm long, and if I can just find some that are 10mm long, the space here is 10mm, so this screw will go exactly nicely on the end there and won't stick out like it is at the moment. If I can't find any short ones, I can just cut this one down, so it shouldn't be a problem. And these ones here, or this pin at the back, is just sort of sliding in there at the moment, but for the final thing, to stop it from sliding in and out, I've made one that's the exact right length for this, so that's going to fit exactly in that, left to right distance. And I've made these little stopper things out of FR4, just a little piece of that, nice and light and stiff, and I'm just going to screw those across the top of the bearing. These bearings are flanged bearings, so they're really quite handy for this purpose actually, if I can just focus. So you can see one side of the bearing is a little bit wider, has a bit of a lip on it, or a flange, and the other side, I couldn't have asked for a better bearing actually. They fit perfectly in these 3mm plates, so it's perfectly flush on that side, but this one is just sticking out a bit, so that means it can't be pushed through the plate that way, but it could slide out. So that's the reason why this piece is on top of it, so that will stop it from sliding out this direction. And it also means that my pin that's inside there is held in place and can turn around, and it's not going to slide out this side either. So I thought that was quite good, and it's nice and light. These little screws don't weigh much. Originally I had some crazy ideas about, where is it? Here. I thought I might try drilling a hole into this stuff and then using an M3 screw, or maybe M2.5, whatever that is there, M3 I think, and try and use a screw and a washer to hold this pin in to stop it from sliding out, like one at each end. And that didn't work out too well, because this steel that these bearing, or these, what do you call them, sliding rods, what do they call, linear rails or whatever, is really hard steel. And I broke my tap when I tried to put some thread in there. You can maybe see there's a little bit of thread just inside there, but I only got it in a few millimeters or so, and then it just broke off. There we go, you can see the thread. So that wasn't going to work. So anyway, it will work out nicely with these little stopper things on the outside. Here's my next test prototype of the elbow section. This is what I'm going to call the elbow anyway, the sort of middle piece of the arm. It is mostly the same, except for now it has to accommodate a 30mm diameter pipe going through it instead of a 12mm pipe, and that is quite a difference. It's more than twice the diameter. So there were just a few complications caused by that. Obviously everything has to be slightly bigger, or these plates here have to be slightly bigger. And this section here, which is where the elbow is going to rotate around on its mount, this had to be brought down a bit because the bottom of this pipe is now going to be about there, the bottom of my finger. So there's just going to be about 2mm clearance between the 8mm shaft that goes through there. That was pretty easy. It means it can't be symmetrical top to bottom, but I don't mind this shape. It's sort of a bit of a bulge, not a big deal. Also at the back here I had to change this central plate a little bit. You can see that the bearing, now that it's so big, is actually coming right on top of where the screws are that hold the stepper motor on. So I wouldn't have been able to use those screws normally. And it was also crossing across the little bump that these stepper motors have. You can see just at the just here there's a bump, sort of about a 20mm radius bump that's 2mm high or so, and that was also getting in the way of things, and these screws here of course were getting in the way too. So what I've had to do to get around that is I've made a couple of plates here that you can see there's two more 3mm plates there, and they just basically these bumps that I was just showing you, the bump for this screw and the bump there for that round piece, are actually living inside this, or one of these. Let me just I'll take that off so I can show you what it's like inside. So this plate just has normal holes that are the diameter for these screws to go through, just like that, 6 of them there, and nothing special, and it's going to connect the motor with just the bottom 2, and the middle plate has slightly larger holes where those bottom 2 go, and it's going to go around the heads of those screws like that, so that from this angle they're not protruding, they're not getting in the way there. And it's got a little bit to the outside here, so now we have 4 holes. These 2 holes at the top can be used normally, and these 2 holes needed to be sort of a little bit up and further away, so we can still secure these points to the main plate, but now they're going to be, let's see if I can show you this. Here we go. You can just focus that. So now we've got these 2 points there just under my thumb and there just under my thumb, and those are not going to be in the way of this large bearing, and I can still get at them with my screwdriver to tighten things up. And as you can see, the holes on here are sort of elongated so that the motor can slide up and down a bit. Anyway, that's how that works. Other than that, I have not changed anything, although I have removed those 2 rollers that we had in here, because now that this pipe is so large, we don't actually need to squeeze the belt in. We don't need to make it narrow to go into the pipe. It can just hook straight over this motor and be pulled tight, just in a sort of straight line, 2 straight lines like that. So the total weight for this upper arm section, or lower arm is it? Well, the point from this bearing, where it swivels on there, down to the gripper, it looks like it's going to be about 550 grams, which I think it was 500 grams with the last version. So I've added 50 grams to it by this, with this version, which is not that great. It's sort of getting to the point where we're bumping up against the edge of the limit of that test that we did. So hang on a minute. The test that I did outside in the garage, where I was, I had the heavy weight on the lower part of the arm, and I was testing how far it could go down without slipping and stuff. I did that with 410 grams at 33 centimeters from the axis, and if I divide this by, what did I say, 550 grams, that means that at 24 centimeters or so, this 550 grams weight would be applying the same torque as the 410 gram weight was at 33 centimeters. So as long as I don't make the lower arm, or the main part of the arm, the first joint, first link, whatever, as long as I don't make that more than 24 centimeters, it should be able to manage, because it will be within the range of the torque test that I did before. But I'd rather it was a little bit lighter. And I noticed that one of the components of what I was planning to use for this, which is a 8mm bolt, So this was going to go in there, and it would work fine. It's just the right sort of length and everything to go. The outer plates will be on here, so it's just the right length. But it's bloody heavy. It weighs 35 grams just by itself. So I'm thinking I might replace this with a carbon fiber tube. I have a nice wrapped carbon fiber tube, 8mm. It's a little bit narrower than this. I might have to put a little bit of sellotape around it to bring it up to the right diameter to not have any slop in it. But it'd be a hell of a lot lighter than this. So we could perhaps make this whole upper section 515 grams if we tried a bit harder by doing things like that. And a couple of other pieces I made are this large gear pulley. This is a 96 tooth one, and this is going to go on here. This funny arrangement of holes matches up with that on there. Isn't it great to have a CNC machine where you can do things like that? There we go. It all has to sort of be lopsided, but I wanted to spread them out fairly equally. And so this is going to attach directly to there, but it's going to be sandwiching this, again, flanged bearing. These are quite handy for this robot building purpose. So it's going to press in there, and it fits in there quite nicely, but I'm not going to put it in now just in case I need to take it out again. And the more you press them in and take them out, the looser they get, it seems. They sort of stretch or, you know, rub on the acrylic so that it wears down, and next time it seems to be a little bit looser. So I want to keep that to a minimum. But anyway, this is going to go on there, and then this is going to turn the elbow joint like that. And this piece here is not sure how well this is going to work, because this is going to have to go over the carbon fiber to turn the middle section. And one of these ends is, there we go, goes on one end a little bit easier than the other. But I'm thinking I might actually put it on the end that it's hard to get onto. I can just get it on this one. And that might actually work in my favor because, sorry, let's get the mouse off the screen. That might actually work in my favor because I think it's actually strong enough there that I can use that as the final drive connection. Yeah, I think that'll be good enough. So again, I don't want to be pressing this off and on too much. But if that doesn't work, I might be stuck with having to drill a few holes in like this and putting those grub screws in like I tried with the aluminium inserts. Unfortunately, there is not enough room to put aluminium inserts in here, so it'll just have to go straight into the acrylic, and hopefully it won't split the acrylic or crack it or anything like that. But I don't think I'll need to add too much clamping force with the grub screws, because like I showed you, it's going to be pretty tight on this end. And speaking of pretty tight, the next step is obviously to make a cut in here somewhere and try assembling these two sections so that I can see how the belt tensions out and everything. But I'm a little bit reluctant to do that until I know exactly where I need to cut it. And I'd like to keep the cut length to less than half of the length of this, so that if I screw it up I can make another one using, I'll have half of the pipe left instead of having to wait another 3 weeks to get it again, because I only bought one. They weren't really that cheap, this pipe. So until I know exactly where I need to cut it, or I know I don't need to cut it more than halfway, I'm just going to hold off on that for a bit, because one of the problems is I only have a limited selection of these belt lengths, because I've got some of them from Banggood, and there wasn't a very good selection on Banggood. There's a little bit more now than when I first started buying them a few months ago. But there's a 400, and you can also get a 610. I think they have these on Banggood as well, and I got this one in New Zealand actually on Trade Me. But what I really need is something that's sort of in between these two sizes. And for a while I was a bit stuck, but then I discovered a website called Robot Dig, I think it was. And they have lots and lots and lots of different lengths, and they're all very gradually increasing in length. So you can just pick out whatever kind of length you want. And I've ordered some of those, and they're on the way, and when they arrive then I'll get on with my next step of cutting this pipe. The other reason why I'm a little bit reluctant to, or a little bit scared to go on with the next step, is that these bearings are extremely tight on the pipe. They don't go on at all on one end, the end that I just showed you. They will go on to the other end, but you can only slide them on to about here, and then they get stuck. So I might probably have to sand this pipe down a little bit to get them to move over a bit better, or I could try a little bit of lubrication and maybe put another tightly fitting pipe over this and tap down with a hammer to get them to where I want them to go. But either way, that's probably going to leave a lot of scarring on here or mess something up. In any case, what I'm trying to get at is that I want to know exactly where they're going to have to go before I start trying to put them on. And the other thing is you've got to be careful, because you've got to put them on. You've got to put that one on, and then you've got to put this in the middle. Make sure that's in the middle. Yeah, anyway, I just want to do it carefully, so I'm not going to rush into it. So that's where things are at for the moment, and I hope that was kind of interesting. And when something else happens that is even more interesting, let's hope, I will keep you updated. Thanks for watching.